Good day, good evening, good morning, wherever you happen to be joining us from. If you're watching this live, welcome to today's Jumpstart. We're going to be covering some very interesting topics today. This one happens to be around building Linux, OSS, and other solutions based on Microsoft Azure platform. I'm Rick Claus. I'll be your host for the next couple of hours. I'm going to be joined by a variety of speakers. I've got Boris Baryshnikov here that's going to be joining us in just a moment. But first, I thought I'd go through a little bit of housekeeping here for you if you're joining us today. The first part I want to mention is, from an agenda perspective, we're going to be looking at 4 different topics: Linux data options in Azure and how to be able to go off and use and configure them; building and accelerating a DevOps pipeline on Azure. That's going to be with Kundana, is going to be joining us; building and managing Docker-based multi-container apps on Azure; application platform as a service on top of Linux virtual machines on Azure. Lots of stuff that's going to be going on today. Very, very interesting topics that we're going to be covering. We'll be swapping different people in and out. Each session is going to be approximately about 50 minutes or so from what we have currently on our agenda. But you are able to interact with us if this is live. You can, if you're registered as a registered user on the MVA platform, you can simply go ahead and use the Q&A live chat on the right-hand side to be able to go off and to ask us questions, say hello, and ask for clarifications. If you're not registered, because you do not need to be registered to attend and to watch this particular webcast that we're doing, you are able to go ahead and simply use Twitter with the hashtag of MSMVA on Twitter, and that will get your questions bubbled up to here, where I can go ahead and ask Boris and other presenters those individual questions. And then finally, if you have some feedback about this particular Jumpstart or about the state of Linux and open source on Azure in general, if you have any questions or concerns or anything along those lines, you are able to go ahead to the user voice feedback form. The link is on the slide that's right there. It'll be available in the handouts notes as well. Basically, it's feedback.azure.com, and then you'll be able to choose the virtual machines feedback area. That's principally where the Azure Compute team tend to spend a lot of their time viewing issues and discussing issues that come up on the Azure platform. So very simple, feedback.azure.com. It's a user voice form. Just on the right-hand side from there, choose the one that represents virtual machines. Without any further ado, let me have Boris introduce yourself a little bit and say what you're going to be talking about today. Boris, welcome, by the way.
Thank you, and good morning, good afternoon, wherever you are. So my name is Boris Baryshnikov, and I'm a program manager in the Azure Compute team, and currently I'm focusing on Linux and open source things, and today we're going to be talking about data. So data on Linux specifically.
Data and all sorts of stuff.
Data and all sorts of stuff. So the idea behind this is to show you what you can do with data on Linux. So yes, there are some solutions that you can get today, and what can you deploy yourself, what can you run, and what kind of things you can do in Azure. Basically focusing on open source kinds of solutions.
And so what team do you work with on Microsoft specifically?
So the big team is called Azure Compute. So this is the team that's responsible for the Azure Infrastructure Services. So that's the team that would manage virtual machines effectively. That's what it is.
And your background for the stuff that you've done?
So that's a good question. So thank you actually for reminding me. Previously, I worked in the data platform group. So probably for about 10 years in the product like SQL Server and Azure SQL Database. So working in the query optimizer, query processor team first, and then that's building the on-premise SQL Server solution. And then probably for the last 4 to 5 years working on the Azure SQL Database. So that's building the Microsoft provided database. So this is a fully managed solution. So this is one of the options on data, that you can have a solution fully hosted by the cloud provider, and the Azure SQL DB is one such solution. Again, today focuses in the open source, things that you can do yourself, things you can run yourself, and kind of that's what we're going to be talking about.
Very good. I've just brought your slide deck up for a little bit of, I guess we're going to be going through a little bit of architecture first and some background and different sort of options, that sort of thing.
Right. So we'll look at what are the unique characteristics of data option workloads, or data workloads in Azure, and what makes them requiring special considerations if you kind of look at this closer. And now looking at that, we'll take a look at what platform provides. Like what are the things the platform can help me do to make sure my data solution work well. Again, this is not a question for the solution that's fully cloud provider operated, which means we take care of all the details absolutely and completely, versus something that you deploy and run yourself, where you need to account where you deploy, how you deploy, what kind of resources you use, and what platform can do to help you manage that solution easily. So that's the idea.
Okay. If you could just bring up the slide for one moment there, Danny, just so everyone can see, this is Boris's email address for any kind of questions you have after the effect. You get tons of email after this, thanks.
That's good.
And then also, I see you can put up your Twitter handle there as Boris B2015.
Right.
I'm @RicksterCDN if you wanted to pop up some questions on there too. But I'm going to get out of the way and let you go ahead and get started.
Sure.
You're all set to be able to get us kicked off with a little bit of background, and also I hear you got a lot of demos too. So.
Right. So we'll spend probably first half of this hour doing some theory, if you wish, and look at the various data options, what things we need to be watching for when we're deploying data solutions, open source data solution in Azure. And then we'll switch into the portal and we'll look at various things we can do in the portal to make sure that thing deploys, things work well, how we can monitor stuff, and anything else related to this. Through the deck, I actually have a lot of links scattered around, so that's the idea behind it. So in many cases, you have to go and read more on any particular area. So the goal of the session is actually to cover breadth of options as opposed to depth in any particular area.
Yep.
Again, open source variety is quite significant, and in this sense, we want to focus on things you just need to be generally aware of, as opposed to focusing on any particular solution. We will spend a lot of time on relational database because that's probably the easiest and fastest as far as demos go. So that's, but we can look at the other pieces if you wish.
No problem. And it's just for the people that are watching on the right-hand side of the screen. If you're watching this in smaller screen mode, under the Fact tab by the just next to the video, there is the location for where you can go ahead and download those slides. At this point in time, slides for Module 1 and Module 2 are not available. They will be available a little bit later on today as we get caught up. As it is traditional with most presentations that we do, we're always making tweaks just before the very, very end. So bear with us. The slides will be available, and you will have access to all those links that you're talking about too.
Sounds good. So let's switch back to slides and look at the slides a little bit more. So let's look at the planning for data workloads and what are the unique pieces of the data workloads are, and see what we need to be concerned about when we're deploying various data solutions in Azure. So the things you see on the slide right now, this are generally the technical considerations that one needs to take into account when looking at the data solutions. Actually, pretty much any data solution, be that open source or not, and actually any cloud provider. Usually data characterized by things like usually working with a lot of data. So size of data matters, and it matters in terms of where your data resides, where the consumers of the data and where the generators of the data are. And in case of Azure, so you're paying for the traffic for the data coming in and out, and you have a certain limits on the different VM sizes and different storage accounts where you can where you need to watch for if your data will basically fit. So that's one of the considerations. The second important consideration for data workload, and it's probably pretty much across the board, relational, NoSQL, or otherwise. This is the resource usage in terms of memory and CPU. So data workloads tend to be memory intensive, so favoring bigger machines for production workloads, that's again the choice that you need to make. The very important aspect of the data workload, and because the data normally does not fit in memory, we're talking terabytes of data versus gigabytes of RAM, and various levels of processing, schemes like MapReduce, I/O performance becomes important. So in this sense, again, looking at what options you have for I/O, what options you have for storage, and how that storage plays into the picture in terms of perf, that's important consideration as well. Next one in the list is network bandwidth and latency. So commonly, when you look at the application that's built on-prem traditionally, this is a server that's kind of well configured, tuned, and probably pretty big for the workload. And usually latency is pretty low, and you have pretty much the hardware regulated bandwidth. So it's all up to you how much you use. In Azure, there are different quotas, so to speak. So if you go smaller VMs, you probably have a smaller bandwidth available to you, and if you have a lot of chatty applications, so you have to pay attention to latency. So based on where your consumer of the data and where your data provider is, so that may also play into the picture in terms of overall performance. Again, that's the final consideration for the data workloads themselves, is what's your overall performance compared to on-prem. So that's the consideration. And
just from a deployment perspective, this is the kind of thing where during the test dev phase and the pilot phase, you can start off with smaller instances of machines, see if they perform adequately enough, and then if not, you can always go in and potentially redeploy in a slightly larger instance?
This is correct. So this is one of the beauties of Azure. So you can start small. You can start, actually, this is where the cost efficiency comes in. And actually, with that, let's take a look at the next slide. So in addition to our usual technical considerations, things that are most likely resource related, so there are other considerations that are, you can call business considerations, right? So when people deploy data workloads, they worry about things that you see in the slide right now. So things like availability. Can I always access my data? Is the data 99.99% available? What about security? Where is that data? Who can see the data? And can I actually do the auditing on the data itself? Things like, what if there are disasters happen? There's some, God forbid, earthquake in a data center area. Would my data be protected? Then obviously, when you have a lot of infrastructure, when you have a lot of data solutions deployed on your behalf in Azure or any other cloud provider, you want to make sure that your operations management and maintenance of this whole infrastructure and all this software is done relatively easily. So this is what DevOps sessions will cover in greater detail. So we're going to focus on this one in particular. And then the next line is exactly as you asked, so development versus production. So I would like to start small, but also I would like to have an easy way of doing scaling my instances, scaling the resources I have allocated to the production load. So this is what Azure provides. It provides you ability to increase the size of the VM or extend the disks in order to be able to sustain the high throughput workloads versus starting very, very easy, starting with a single machine where you can only do the dev. And then another consideration that often comes up in doing things in cloud, so are you building stuff brand new in the cloud or are you migrating to the cloud? So in this sense, if you new in the cloud, you can actually account for a lot of things that are unique to the cloud, such as latency, the resource availability, various options you can choose from the beginning, versus if you're migrating to the cloud, you probably made assumption, or your application have made assumption for what it can do, how fast it can reach the database, what the latency between the queries and things like that. And that not necessarily will migrate easily. And finally, important characteristics and one of the benefits that Azure provides is cost. Right? So as we will see, Azure itself provides hourly for storage or per minute billing. So that also helps you cut on the costs in terms of how much it costs to run this data solutions in Azure. So for example, you can stop VMs at night if you're actually only doing the development of that as opposed to production, which is 24/7. Now, so those are the important things for the data workloads themselves. Now, let's take a look at what Azure platform provides as far as services. So what helps me, what does Azure have in terms of building things up? So again, this is a quick diagram of what the Azure solution, what the Azure is. So you have a number of clients that go through the load balancer, and that load balancer routes traffic through the network to a number of VMs. Could be one, could be many. Usually in production environments, always many. Which those VMs run on the Hyper-V layer, on the physical host hosted inside of the Azure, and then the storage itself is provided through Azure Storage, which could be either remote or in some cases could be cached, and you have a local disks, which are a temporary disk, which we'll talk about a little more. Now, if we look at this single picture now abstracted to the larger set, so what you can see in here that you usually have racks of those servers where all of your VMs are running. And then those racks combined in so-called stamp, and then there's a number of those stamps or clusters in any particular region. And that the region, those data centers usually connected by high-speed network connection. That's where, again, depending on where your application is and depending on where your data solution is, you may have to account for that latency. And then,
but just before you go on, just for this particular one, now this is the I want to say the 5,000-foot view or 10,000-foot view of how the data centers are currently structured for how traffic comes in, comes out. So when I look at this and I see cluster, I'm not thinking about like a MySQL cluster, or I'm not thinking about a compute cluster. Actually, this is the term that we use to basically describe the stamps of how we deploy machines within our data centers, correct?
That is correct. So it's actually a very good observation. So cluster is unfortunately abused word. So there's everything is a cluster. There's cluster this, cluster that. Yeah. So this was specifically referring to the fact that you have a lot of machines, and those machines are in the regions and stamps, and those are connected between the regions through the high-speed networks.
Right.
But again, this is not a next to each other machines, so there's some latency involved, and you have to pay attention to that.
So ultimately, when you say deploy me a new machine using this image in the Azure Portal or through the Azure CLI or through PowerShell, it's going to end up on one of those individual servers that are acting as the hypervisor, and it's simply going to be a VM on top of that.
Right. So effectively, what you're doing when you and we'll see that in a little bit later in the demo, when you instruct through the portal or through the CLI, you authenticate yourself to the APIs, to the backend of the Azure, and you tell it, please give me the VM of this particular size with this particular set of parameters as we configure, and then put this particular operating system on this, which runs on top of the Hyper-V layer, and it could be Windows, could be Linux, and then on top of that you deploy additional software, which is your data solution. So that's the way that's the way it goes.
Good.
So let's go back and look at the platform services more specifically. So this is a list of things that we will briefly cover. The virtual machines, storage, network, availability sets, so that's important characteristics for high availability as well. Various security features, backup and disaster recovery features, and we'll touch a little bit on the deployment and management. Again, a lot of deployment and management will be covered in the later sessions. So we'll just make sure that to cover only the basics so that you will be able to proceed with the initial deployment, and then you look into more details either in other sessions or by reading the additional documentation.
Sure.
Now, let's take a look at the VM sizes. So the reference on top of the page will take you to the virtual machine specifications. This is the textual descriptions. This is not a pricing page. And this will tell you what are the different classes of the VMs we have. And to basically recap, there are 4 different series of the VMs. Standard series, A class, D series, DS series, and G series. So A series is what has been existing for a long time. This is the most basic machines, and they number it as they grow bigger in terms of the resources and in terms of the various things you can have on them, such as number of disks attached to them and the network throughput available to them. D series VMs feature SSD drives, SSD temporary drives, and they're a little bit faster. Again, there are a variety of sizes in this. DS series is the special series that actually would benefit a lot for the data workloads. Those VMs are capable of using so-called premium storage, and we'll focus on that a little later. Premium storage provides a lot more throughput and a lot more IOPS that you can do with them. And then the G series, those are the largest machines. You can guess why they call G. I guess that will be the pop quiz at the end of this presentation. And those usually get the largest available amount of resources that you can get in Azure as of today. Again, this is as of today. As the new hardware comes, I'm sure the new series will pop up. I'm sure their new numbers will show up. And then there are special series in some of those classes. For example, 8 and 8.9, 8.10 and 11. So those are the compute-intensive series. And 8.8 and 8.9 usually are the network-optimized instances. They have InfiniBand and RDMA support on them. So usually the batch workloads are things that use them. But again, you can run various other NoSQL solutions that require a lot of data aggregation and shifting data around. Again, those are, as you progressively go to higher, bigger VMs, they're becoming more expensive. You can start small, and then as you go towards your production workload, you can scale them up transparently to the application and usually transparently to the workload. So one other consideration here to call out, so not all sizes are available everywhere. If you go and look at the Azure CLI, so in the R mode, you can do Azure location list. They will show you all the locations available to your subscription, whoever you logged in as. And then you can also look at Azure VM sizes, and you need to pass a location as what VM size is available in there. And we'll take a look when we get there for the demo.
You just mentioned Azure CLI, just so in case people don't know, that is our command line tools available for being able to go off and work with Azure that works on Windows platforms, Macintosh, Linux, and OSS, and other types of solutions as well.
That is correct. So Azure CLI, Azure Command Line Interface, this is a set of tools, and I'm running it on Mac in this case. So this is kind of, I can easily transparently do commands on Mac and shift to Windows and do, so on Windows you can also use PowerShell, which is a preference for some people, but then again, you can still control Linux VMs through PowerShell, but in this case, I'm mostly focusing on the Azure CLI.
No problem.
Switching to the VM sizes, and one of the things that to be aware of VM sizing, you can start small, you can start in a small instance. There are some choices that you need to make up front. If you ever plan to use the premium storage accounts, then you have to start with the DS series VMs. You can still start building it up on a standard storage for cost reasons. VMs do have per minute billing, so you can actually stop them. And stopping a VM, one thing to be aware of, if you shut down the VM from within the VM, you can have you can actually have VM stopped but not deallocated. So there are two states the platform distinguishes. One of them is called stop, another one is stop deallocated. When you have VM in stopped state, you're actually preserving and have a lot of resources still allocated to that VM, so you continue to incur charges for it. So if you want to actually stop the VM and not pay for it, let's say you have 8 to 5 workday, you only want to do 8 to 5 development and then don't run it on the weekend or at night, you can stop and deallocate the machine from the portal, which would put it in a state when you're not going to get built and disks are not going to get deleted. So the next time you come and just start the machine, it will help you get back to the state it was. But again, this saves you on the cost if you want to do so. Now, what are the other things to be aware of for the virtual machine sizes? There are a number of limits that are proportional to the VM size. One of them is network bandwidth. The bigger the VM, the more you can actually saturate, the more network bandwidth you get. So if you start small, you may be limited by this factor. If you go in production workloads, you probably have to go to a larger VM. They also, with the size of the VM, the support for the maximum number of data disks goes up. And each data disk in the standard storage has 500 IOPS. So if you have data-intensive workload, a lot of data being written or read from the disk, you probably need a lot of disk attached to the VM, so you're actually also bound to be getting a bigger VM to proceed with the production workload. For the premium storage, the number of IOPS and the absolute limit of how many megabytes per second you can move in and out on the premium storage is proportional to the VM size as well. Again, this is something to be considering when you're building a solution, when you're building a data solution. So as far as the max sizes, this is more of a kind of trivia page. As of today, you have almost half a terabyte of RAM on the G5 series VM, and with 32 CPUs, and you can drive as high as 32,000 IOPS on the standard G5 storage VM, and you can have up to 50,000 IOPS on the premium DS14 VM. Again, this just shows how much you can push through the system for the data-intensive workload. But that's for data-intensive workload, that's typical, and that's common to have a high throughput rates. Maximum number of disks supported is 64 for the G5 and 32 for DS14 for the premium storage. Again, this determines how much data you can push and hold in a single VM spread across multiple disks, and how much raiding you can do in terms of the disk. So let's switch to premium storage. So storage is one of the important considerations here. And again, reference will take you through nitty-gritty details of that. Premium storage requires a premium storage account. You either create that before you create your VM, and then you place your VM on the storage, and you have to create a DS series VM to be able to use a premium storage. You can build, you can use premium storage as of today for disks only, for the blobs. And the bigger disks, so the bigger disk you allocate, you will get bigger bandwidth in terms of how much data you could push into a particular disk. And then as you go to the bigger VM, such as all the way to DS14, you have the highest throughput rate. Again, the idea behind it: you start small, you start dev, you start testing, then you scale it up, you do your perf testing, see if that's sufficient, and keep it at a particular range in terms of what size you need. For the considerations how to build such a VM, normally, if cost is an issue, you can build using standard storage for the OS disk, and you can push data on the premium storage. That usually requires some configuration changes in terms of what you deploy, and you can do that through the templates, or you can do this manually when we'll see that in the demo. So the other considerations for the storage, different storage accounts, such as standard versus premium, have different limits. Things to check for: maximum size as of today of the premium storage account is 35 terabytes. So if you actually want to hold more than 35 terabytes of data, then you have to spread through multiple storage accounts. And there is a maximum total bandwidth limit for the premium storage accounts, something like 50,000 IOPS If I remember this correctly, again, reference page will show you the target numbers as of today. Usually that means if you need to push through more IOPS than a single storage account provides, you need to scale through multiple storage accounts and put separate data disks on a separate storage accounts. The other factor to consider here in this documentation article that's listed on the slide, there are some recommended distributions that we actually have tested. So we verified that all the drivers and everything else is actually working correctly with the premium storage. Again, this is not a requirement, but usually they will give you the best performance as we are aware of as of today. And our goal is obviously to extend that set in terms of Linux distributions available. The other important consideration for the premium storage, it's billed hourly per maximum storage size. So usually in increments of either 100 gigabytes and bigger sizes. So it's not built per size as it is in the standard case. In the standard case, you pay some cents per gigabyte, whatever you use. In the premium storage, you actually, of whatever your minimal size disk, round it up to the next highest larger number. That's what you're getting billed for, and it's billed per hour. Again, you can bring it up, you can work through that, and then if you push the data, and then you can take it down, and you'll be billed on that disk size on the hourly increment. So you can actually do this cost saving as well if you need to do so.
So this has been a very broad discussion around performance with regards to just simply machines, machine families, architecture, and then also disk subsystem for your IOPS. And this is all the kind of stuff that you would normally do anyway if you're trying to spec this out for an environment that's in your on-premises environment. But now you're doing it inside an Azure environment, and so you have to bring in the extra considerations of how many attached disks to be able to get the IOPS, and then as you mentioned, the size limitations and being able to pool these disks together in a RAID format to be able to go off and to get the IOPS spread across accounts to be able to maximize your throughput. And I like how you always go back to the beginning of saying, start small, make sure it works, make sure it's all fine. Doesn't meet your performance requirements, then take it up the next notch, take it up the next notch to be able to go off and to redeploy.
Yes, so that's one of the beauties. Again, the whole point of covering this all is to be aware of different options Azure provides. So in this sense, you can look at, let's say, if you are intended to use premium storage, if you intended to benchmark premium storage for whatever data solutions you're going to deploy, you can start with the DS series, with the smallest DS series VM, run your tests on the small environment, and then scale it up, do the rated disk, and see what happens in terms of the perf, and then see if the price benefit is what you're actually looking for whatever solutions you're deploying. So let's keep moving, as we have a lot of, I guess, theory to do, and then we still want to do some demos to see what you can deploy. The other thing to consider in the storage case, there are different caching modes. I'm not going to cover that in detail here. Again, the storage redundancy link will tell you what they are. The default choice is usually that's what you would keep. The data disk, that's where you keep majority of the data, usually has no caching on them, and the OS disk usually have read-write caching. And you can also use read caching for the premium storage accounts. Otherwise, we just recommend not setting caching for data disks at all. And then for perf reasons, you do want to keep data on the data disks as opposed to on the OS disk. For the development purposes, for investigation purposes, it's okay to keep it on the OS drive. Now, the other important consideration to call out in here is there's a temporary disk attached to a VM. And the uniqueness of that, I guess the thing to consider about this is the disk itself is, it stays with the host. So if you think about it, when the VM gets reallocated, for whatever reason, it's a planned maintenance, or you scale the VM up and the VM has to actually go physically migrate to a different host. Remember that picture at the beginning when we had a layer, the Hyper-V layer running on a particular host, and if you're making a VM bigger that doesn't fit on this physical host, we have to move it around. So moving it around loses the content of temporary disk. And technically, you could use temporary disk as a fast local storage. And it could be okay if you have set up replication in such a way that losing that data through either planned or unplanned failover will let you rebuild that replica someplace else on a different machine. Again, this is a consideration if you're building a solution. By the way, this is how internal Azure SQL databases work. They use local storage, not a temporary disk per se, but they use local storage and they do their own replication. So when the VM goes down through either planned maintenance or unplanned maintenance, the replication of the solution itself can build a brand new replica out of existing quorum set of the replicas. Oh, okay. So it's okay to lose that data. Again, this is not okay if this is the only data location you have. Now, with that, let me briefly talk about availability set. So availability set is a feature or a concept in the Azure that allows you to take certain guarantee in terms of how the VMs are taken down through the planned maintenance. So obviously, you should plan for a couple of events. One is the planned maintenance. That's when, let's say, Azure runs OS updates, security patches, right? So it will take VMs down in the availability sets only one upgrade domain at a time. So, and then taking that one upgrade domain at a time guarantees that the other VMs in that availability set can actually stay up. So you have a quorum of replicas, and that will help build your availability set. So if you have just one VM, we cannot guarantee availability because we have to reboot that VM once in a while. We have to move that VM occasionally, right, for the hardware deprecation reasons. And it takes time to reboot the machine. Even though that might be short, it's still time. It still will not let you set the SLA. If you have multiple VMs in a single availability set, then you will have ability to actually maintain SLA. There's only one VM in the UD, so one UD at a time can be taken down. Now, when the planned upgrade goes, the other consideration here is that we take UD down, upgrade it, bring it back up, have a pause between the next operation, then they take next UD down. This pause right now is about 20 minutes. So that's the time you have to recover other replicas if you have if you're using this, if you're building your own solution, or if you're using third-party solution that relies on this functionality. The other consideration here is the looking at the various traffic manager and the load balancer. Again, link in the slide will take you there, and you can look at the details in terms of what you could do with the load balancer and the availability sets.
I just noticed on the Q&A session that's going on right now that your slide deck is available. So if you're watching this live, under the FAQ or FAQ section on the main page, you are able to go ahead and download these slides and get access to all of the links.
And I guess one of the, I'm assuming this is PowerPoint that's becoming available. So if you go in the slide and just select the link and say Control-K, you will be able to grab the link and copy paste it elsewhere, as opposed to running in the presentation mode and clicking on the link. Again, this is just a usability feature.
Sure.
Security backup and disaster recovery features relatively quickly. So the Azure backup today can take you the snapshots of the VMs for the disaster reasons and for recovery reasons. Disk encryption extension coming soon. This is a native disk encryption, including the OS disk. So this is a concern that often comes up for data solutions. Where's my data and who can see the data if, let's say, bad things happen? Or if somebody steals the data, and then what do you do? So this data could be encrypted. Again, we demoed this in Ignite 2015, and that encryption extension will be coming available soon for the general consumption. And then storage redundancy is something that to be considered. There are various levels of storage replication. And when you run with the premium workloads, this is locally redundant storage. So this doesn't protect you from, let's say, major disaster in a single region. Let's say this is earthquake, or some fire in the whole data center that burns everything down. So you need to make sure you take snapshots or use backup to move that data elsewhere. So if there's a major disaster happens in the whole region, you have your data elsewhere so you can actually continue your business after that disaster happens. Again, this is not availability feature. This is disaster recovery, business continuity kind of feature. Software configuration, another, probably the last one I'm going to cover in this list. Do make sure you look at the endorsed distributions, and do make sure you have the latest versions, latest drivers installed. Very often we do find some performance characteristics of a particular distribution, and two components that are important in running on the VM in Azure. So one of them is called Linux Integration Services. This is the layer that provides what's called, we also call it enlightenment of the VM, so that this is how Hyper-V running on the host knows that it can interact with the guest OS, in this case, Linux operating system in the guest VM. So this is what the latest drivers usually have perf fixes and have additional modifications. Linux agent is a component that interacts with the Azure itself. So this is something that provides a lot of information in terms of VM health, in terms of deploying extensions, things like that. Again, this is a separate topic. We can cover that as a distinct session. But again, having the latest versions of those two components usually helps making sure the perf is good. Obviously,
you're recommending that they use the existing images that are there as part of the Azure environment to be able to do stuff. Are people able to go off and to bring their own distributions?
Absolutely. So this endorsed distribution simply means that either us, Microsoft, or our partners have verified that those run and they have the latest perf and security fixes, and actually perf usually comes up as the first one. For example, latest CentOS versions have a lot of fixes that if you're running on 7.0, you have a bad storage perf. If you move to 7.1, which is the latest supported, then you actually get, you should be able to see significant perf boost. So we do make those tests, and that helps us make sure that you actually get that in your data solution or whatever else you're running. It's actually not limited to the data solution.
Good.
So let's go into deployment, configuration, maintenance, and after that we'll switch to demos. In terms of what are the different things you can do for the data solution, so one first and foremost, and that's the one I would actually recommend you can do after you watch this session, just go sort of roll your own, create a VM and deploy a data solution, and I'll show you where you can do that. So the quick ways to do is to use one of the templates, or you use one of the gallery images that have a data solutions already built in them, so you can actually see and play with it and do the perf testing, do the configuration changes. So we'll look at that in the demo part. So templates are the Azure Resource Manager templates. Kundana is going to be talking about it a little bit more, and Madan. They help you group various resources together, and they help you actually have consistent picture of how you deploy things. And then there's gallery images, either standalone, which means you run just on the guest OS, whatever software you're deploying, or there are lots of now Docker images. Again, Rick is going to be talking, Ross is going to be talking about various containerization things you can do today so that you can actually quickly assemble your application out of the containers. And then there's obviously fully managed solutions that you can have in Azure. Again, this is things like ClearDB, things like MongoLab, that you can have a solution managed by third party. You don't have to configure anything. You just provision that solution and pay for that solution. Now, in terms of maintenance, how do you upgrade? How do you make sure things are current? So usually people use extensions. The couple of them I'm going to call out is the custom script extension for Linux that allow you to run pretty much arbitrary script on the Linux VM through the interaction with a Linux agent. OS patching extensions allows you to schedule and keep your OS and other components updated on the VM itself again. Allows you to set the schedule, and that simplifies the maintenance operations. Again, DevOps sessions will cover a little bit more of that in details. And then final piece is the template update. So if you put some changes in a template, the Azure Resource Manager is smart enough to recognize there are changes in here, and it will go and make sure that the change is getting deployed consistently to whatever environment you're deploying it. So I think that's all I have for the theory part. So we have about 10-12 minutes to actually go and look at the demo. So let's go look at the demos. So in terms of what you can do in Azure, so you normally go to the Azure portal. Again, the URL is the portal.azure.com, right? And then that would log you in. In the portal case, just any subscription would do. If you're using Azure CLI, you may need to create the Azure org account if you're using something like a MSDN subscription, because Azure CLI supports authentication through the org account only. Again, Kundana is going to show a little demo on how to do that. So once you get in the portal, again, this is something that you may have seen if you already have it. So you go to the new in here, and I'm working with the Microsoft internal portal, so it might differ slightly from what you see in your production case or in your environment in MSDN. So you go and look at the compute and say, I want to provision a VM. And again, there's a variety of options in here in terms of the OS. If you click on the marketplace and say, I just want to start with a blank Ubuntu VM, right? So in type Ubuntu, they will give me lots of choices with a lot of actually additional software installed on them. And there's different categories in here. So there are basically three things you can get your VMs from. So one is the Azure Gallery, something that's been tested and certified to run in Azure, and we know how we got that. Now there's a VM depot images as well. They're provided by community. There could be great variety of things you can do in here. But again, if I want to start with some basic image, so I'm going to go and pick Ubuntu server. It describes me what it is, various characteristics. So one of the important thing to look in here, so it has this new feature selecting the compute stack, and there's either classic stack or the Azure Resource Manager stack. So today you can provision the VM in two different ways. The classic stack is that what you will see in the old portal, the manage windowsazure.com shows those VMs. If you provision a VM using Azure Resource Manager stack, then this is what the R mode in Azure CLI would show you, and it's not going to show up in the old portal. Again, keep that difference in mind. Depending on the image, you will either pick one, or you will sometimes will not have choice. A lot of templates just don't have a choice because they're using the Azure Resource Manager templates.
I mean, ultimately, people should be moving to using the Azure
That is correct.
template. That's the way of the future for how all templates and resources are being deployed and managed within Azure.
This is a very good point. So yes, this is how we're moving in terms of the Azure. So a lot of features will start showing up in the Azure Resource Manager land only. So yes, a lot of production environment, a lot of dev environment right now working in the classic stack. And in this case, I would recommend starting to explore the Azure Resource Manager. It has slightly different UIs because the concepts are different. You have a lot of resources combined in so-called resource groups. And the resource group, usually that's what combines a number of elements to make sure just a single deployed VM works correctly. And I'll demo that in a bit. Again, the point is not to show the UI. You type the parameters in here. You create the resource group because I have used the ARM mode to create it. You pick a location, you pick a subscription if you have multiple, and then once you hit OK, you get your VM request to create a VM. So I have a few of them created here in the page, and you can pin whatever you're creating on the page, so for easy access. So one thing I've done before this presentation, I actually created the MySQL manual resource group. And this MySQL manual resource group, this is what encapsulates all of the resources in this given particular case. So you can see in here, there's a number of resources combined. So one of them is actually VM itself. Again, if you hover mouse over it, will show you what it is. There's a network card, network interface. There's a security groups that define inbound and outbound rules. There's a public IP address that what gets assigned to. You can have a dynamically assigned address, or you can have a static address, reserved address. There's a virtual network and a couple of storage accounts. So this is, as you can see in here, this is the DS. Actually, if I click on the VM, it will show this is a DS series VM. Okay. It shows right here, DS2 to core 7 gig. And it has two storage accounts. So one of them is the standard storage account, another one is premium. So this is an example of how you would provision a VM when OS is on your standard storage account, which is significantly cheaper than premium, and your data disk is in the premium storage account. Again, to show this a little further, I'm going to go look at the disks, and in this case, you will see that OS disk is separate from the data disk, and data disk is where I have my my data, my database is residing. So let's log into this VM and take a look at what I've done here. Again, this VM, this is the example of roll your own. So I deployed the plain Ubuntu image, nothing on it, and then logged into the VM. So let me do SSH Azure user, and let me actually see what the IP address of that VM. So I need to find out where to connect to. So I have the IP right here. So I'm going to copy that IP, and I'm going to paste it right here in my Azure user and type my password. So here I'm on the VM, right? So you can, as you saw in the UI, I had a couple of disks in there. So one of them, the SDC, the data disk, is the premium storage account disk. So that's the one that has a lot more IOPS, and this is limited to only 100 gigs. And now the other thing I have done in here, so normally you would do something like sudo apt get update to run an update, and then you do sudo apt-get, this is Ubuntu image, install for my SQL server, and then something like this. So again, I'm not going to run that. The idea behind it, I got the VM, I logged into the VM, I run the SQL install, MySQL install, and that what made me MySQL machine running.
It looks absolutely no different than if I was doing this to a box that happens to be sitting next to me, or I was logged onto in the local machine. I'm just doing SSH into it.
This is exactly the point. So this is what you will do to actually do the investigative. Let's say you're looking at MariaDB or you're looking at PostgreSQL to figure out how to make it run. So in this particular case, I also had my SQL workbench in here, and one additional step of the configurations I have done in here on this VM. So first of all, I enabled access to this VM externally. So that required me to actually go in the network rules to define the port to be available. So I clicked on the IP address. So let me look at this. So in this inbound security rule settings, so you can see, let me zoom it in a little bit. So you can see that I actually I opened the port 3306 to be able to connect to this VM from the outside. By default, all ports are closed. The only port that gets open when you provision the VM is a SSH port 22.
Yep.
Again, if you provision through the portal, sometimes portal assigns the arbitrary public ports, so you actually have to look it up at what port I have in here, and I'll show you in the other VM I have provisioned through this portal. Again, this is you deploy the solution now. As I have my SQL workbench in here, let me grab it. So I have my SQL in here, and if I connect to it from my Mac in here, I'll get a query window. I have my table in here, and I can do, let's say, something like select star from table 1, right, and execute that. I'm not sure if I have anything. Yeah, I don't have rows in there, but anyway, so that's the idea. So I have a VM, I have my data solution in the Azure, I have my client that runs on my Mac that connects through the internet. Again, lots of consideration we're meeting in here is that I'm not accounting for network latency, where my app is. Those are the things that you should be paying attention in terms of deploying data solutions. Now, what if I don't know what to do? Where do I do this? So let's briefly switch to slides, and I'll take a look. We'll take a look at the references. So for a number of the open source solutions in here, there's a number of relational choices such as MySQL, MariaDB, Percona, PostgreSQL, and things like that. There's a number of NoSQL choices. Again, those links will take you to either partner websites where they who provide the templates or who provide the solution that run on Azure. And then there's a number of data warehouse choices. So there's a lot less open source things in here. There's things that runs on Linux, but they're not necessarily open source, the commercial software. And there's things like traditional Oracle, IBM, and SAP HANA things that you can run in Azure as well. Again, those links will take you to the page that will help you deploy such a VM. Now, in terms of the resources, again, I sort of glossed over through what you can do in the portal and what you can do in here. So those links will actually take you through the step-by-step tutorials. One of the things I want to show you in the portal, so let's go back to the demo machine. So if I go to the Azure, right, so let's do Azure Resource Manager, Quick Start, Templates. And if templates, if I can type correctly, that would be good. So Azure Quick Start Templates is one of the top links in here. So you can also access it through the documentation virtual machines. Yep. Again, the idea here is that I want to find what is the way to deploy MySQL server. And this has a link to the 3-node Percona XtraDB cluster. So this is the kind of things you can do through the template.
I actually just used that one the other day.
Perfect. And there's a button here, Deploy to Azure. This will take you to the portal. So clicking on that will actually go and take you to the portal, and you'll actually do the UI style deployment. Right. So it will load the template. You can modify the template. Again, this is the specifics of the Azure Resource Manager. And let me, in the interest of time, actually go back to that page. Let me go back. So one other thing you can find on this page, so there's a command line in here. So right in here you have the Azure config mode ARM and Azure deployment. So you can deploy your template through the Azure CLI. So it will prompt you for the same set of parameters, and that will help you actually configure the environment. So again, the idea behind it, you can use the Azure template. You can build it up pretty fast, and that will help you to get started. There are a number of links to go to. Look at the NoSQL choices. Look at the Mongo. Again, going back to the same search window, right? You can just say, I want to look at Mongo, right? So how many Mongo things do I have? MongoDB on Ubuntu VMs, right? So you can go and start with that, or like there's actually even four choices. So.
Now the neat thing about the templates is that they are visible for anyone to see. You can
that is correct.
You can go off and they're on GitHub. You can go off and you can clone a repo down to your box. You can look at them. You can modify them. You can see exactly what's going on. But the template gives you prescriptive guidance, as an example, for how everything gets created, the VM sizes. Maybe they give you options for that, where the data is going to reside on the disks, the extra scripts that get run after the fact to configure it. I was amazed by how fast I could do a 3-node MySQL cluster using the Azure template that's there. Just for being able to support one of the projects I was working on.
And this is
very fast.
So maybe one of the things we could do as a future session, we can actually go through one of those solutions in step-by-step fashion. So we can actually look at what it takes to set up various components. So a lot of those getting started pages, they have kind of exploratory examples, and then the true solution requires a lot more configuration options. So maybe getting real kind of, again, we can ask for feedback and see if people are actually interested in a session like this. We can do a full hour of just doing a full demo data solution of a particular kind. Let's say setting up the MySQL cluster, highly available MySQL cluster in Azure for real production workloads. So that might be an option. So actually, let me switch to the summary slide on the deck and show you a couple of things in there. Again, lots of links in there. My recommendation is go try it out. Pick one, pick a template, pick one of those getting started pages, and if you so inclined, there are performance optimization references as well. Again, there's one on the prior page. So one of the last links in here is the perf optimization for Linux VMs. It shows a lot of interesting concepts in terms of how you can, what you need to pay attention for. And then have any additional feedback, please do send feedback or go to the feedback forums. So that's what you showed at the beginning of the presentation. So please send us feedback. That's where we look. Yes, we do pay attention. Yes, we want your feedback. And I guess happy running on Azure.
Yeah, definitely. Thank you very much, Boris, for joining us for this very first session and kicking this one off. Right after the break, we're going to be back at the top of the hour, kicking off with our next session. So stay tuned. We'll be right back.
Thank you.